I welcome everyone to this video. I am Mr. Ish. We're looking here at an acid-catalyzed reaction at that carbonyl functionality. Our starting point here is benzoyl chloride. That's what it is, benzoyl chloride. Keep in mind, this right here is a way of representing benzene. You know benzene to have two resonance structures, and they are these. An accurate representation of what you have is something like this, which can be rewritten as that. Another way to represent benzene in a short manner is this, and then you bring in the rest of the molecule. That's a way of representing benzene. This right here is a way of representing benzene. We are looking here at benzoyl chloride as our starting point. What is the essence of this reaction? Everything here in the presence of acid and a water medium. We have here a carbonyl oxygen with 2 electron pairs, meaning 4 electrons, there are 2 pairs. It can use 2 of those as a Lewis base and attack that proton. You will demonstrate a protonated oxygen as a result of that. I have used up 2 electrons to generate this oxygen-hydrogen bond. It has lost its normal complement of 4 electrons, hence its oxygen being charge deficient. You can bring a positive sign next to it and it's right to do it. It's a positively charged oxygen, it's charge deficient. I have a water molecule as you see over here, and it can now act in a nucleophilic manner and attack this carbonyl. You can have shuffling of electrons, and you can return 2 electrons back to oxygen to fulfill its charge deficiency. This duplex will be converted into a single bond. When you do that, you're looking here at the water molecule attached right here to this carbon. We have this as our next item coming about. We'll have developed here a hydroxyl functionality from the carbonyl, and the oxygen now has its full complement of 4 electrons. It's no longer charge deficient. You have a chlorine, you have your water molecule attached. This water molecule oxygen will be charge deficient because you see there are 4 electrons around oxygen. 2 of those were lost to develop the oxygen carbon bond. As you saw over here, 2 of the electrons from the oxygen were lost to develop the oxygen hydrogen bond. That's where we are at now. What will happen over here? This proton will leave. When you're looking at this proton, it's just gonna go away, and these 2 electrons which are represented over here will return back to oxygen to develop your double bond, your carbon oxygen double bond, and the chlorine will depart. How will chlorine depart? It will take 2 of these electrons which are involved in the carbon chlorine bond, and it will pull them with it. Now look what will come about because of that. You'll develop here a carbonyl oxygen, and it looks like this. You have your carbon, you have your water molecule which is still attached, and it has a charge deficiency. You have your benzene ring, and I'm representing it as this. When the chlorine pulled away 2 of the electrons which are being shared in the carbon chlorine bond, what developed was this, a chlorine anion which has now 8 electrons. What developed over here from the hydrogen pulling away was a proton. These will combine over here, and you'll have a HCl come off and they'll go away. You're getting the HCl, the hydrogen coming from this oxygen hydrogen bond, the chlorine coming from this carbon chlorine, which was right here. As you see it, you have a HCl. This is where we are at now. Now we are very close to the end of this reaction. What needs to develop is your end product. How will that happen? We also have to regenerate our acid, and we will. I have here a water molecule, and it's in your medium. It will use 2 of its electrons to snatch this hydrogen. These 2 electrons of this bond will go back to oxygen to fulfill its charge deficiency to give you your end product. You will have your end product, which will be a benzoic acid, C double bond O and OH. This right here will form a hydronium ion, and your acid has been regenerated. But what's your end result here? It's a benzoic acid. A carbonyl chloride has been converted into a carboxyl functionality. That's the essence of this reaction in acid-catalyzed water environment. What are your main points? You start here with the oxygen attacking the hydrogen to develop this. You have a water molecule attack the electrophilic carbon of your carbonyl, shuffling of electrons to give you exactly what you see over here. Hydrogen pulls away, the shuffling of electrons going back to oxygen to regenerate your carbonyl functionality, the chloride going away, you have a HCl developed. Now at the end you have to somehow deprotonate this oxygen right here. The water molecule has to be deprotonated. Another water molecule will snatch the hydrogen, and you'll develop your hydroxyl functionality. At the end result, you're looking here at a benzoic acid. We went from benzoyl chloride to benzoic acid, and our acid is regenerated. That right there is the end. Thank you for watching.